Miss Kristen here. Today we're going to do a little algebra, so it'll be review for all my geometry students. If you know it, you don't have to watch it. If you don't, stay tuned. Alright? Now, if anyone else is watching, remember a few things. Sometimes I write like a pirate, and you can't read it very well. But if you listen, I will tell you what I'm writing. And I try to at least catch the things that might look bad. Sometimes I don't draw straight lines very well. And sometimes I'm kind of goofy. So, with all of these things in mind, you can keep watching now. But at your own risk. Da-na-na-na. Yeah, I'm just as crazy in class. Okay, but we're going to start out with some omials. I'm calling them omials because we've got monomials, binomials, trinomials, and polynomials. That's 4 omials. I just like the word omial now. Alright, so a monomial would just be a single term. 1. Mono. Mono means 1. A binomial would be like 2x plus 3. Binomial. 2. Bi means 2. A trinomial would be 3. Tri means 3. It's a little my funny writing again. Okay, so that's 3. Now, a polynomial is 2 or more. So a polynomial isn't really its own category. It kind of encompasses a lot. So I could have, for example, 3x plus 2 that I had before. That's considered a polynomial. Or I could have 7x to the 5th plus 2x to the 4th plus, I don't know, 2x to the 2nd plus x plus 8. That's an 8 down there. Alright, and see, look, and I haven't skipped the third, x to the 3rd, because it's not always there. You don't always have every single one. But because I have 2 or more, it's a polynomial. Alright, it's very unlikely that you'll deal with a lot of these, but just in case, now you've seen it. Alright, so, a couple of reminder things that you should probably learned in class. If I have something like 3x squared plus 4x plus 5, 3 is my leading coefficient, and my degree is 2. So this right here is my leading coefficient. Make sure I spell this right. Coeffiient. Well, that doesn't look right at all. Notice the C. Coefficient. I told you, crazy. Alright, and now this right here is my degree. This is my highest variable amount, so my highest degree right there. So the largest number over the variable, and the variable again is this x. And this x could be a y, it could be a w, it could be a q, it doesn't really matter. It's representing a number that we don't know, that we're going to try to find later. Alright, so there's a couple of reminders. Got my notes down here. Can't see them, they're secret. Top secret. Alright, so let's start with adding and subtracting polynomials. So if I have something along the lines of 4x squared plus 5x plus 2 plus, let's see, can you see this? Move it over a little bit. Plus 2x squared plus 3x plus 1, I can add these set together like this. This right here, I can distribute like so. So I'll distribute, and when you see this plus sign here, you can kind of imagine, and I do have multiple colors, markers, red, you can kind of imagine an imaginary 1 right there. Now, there's the 1 right there. It's really there, but when you multiply times 1, it doesn't really do anything. But when you multiply times a sign right here, like if it's a negative, then it changes. A positive doesn't change, but you never know. Okay, so here we go. So now, I'm going to write it all out again in green. I like green. It's my favorite. So now I've got 4x squared plus 5x plus 2 plus 2x squared plus 3x plus 1. And sometimes my letters have loopy things on them. I don't know why. Alright, so now we're going to combine like terms. Now I'm going for my coefficients. So my coefficients for here, so I've got x to the second and x to the second. So I can combine those. So I'll go back to the red. So I've got 4 and 2, 6x squared. So I can cross those out. Now the next ones that I have that are alike are x's. 5 and 3 is 8. So plus 8x. And then last but not least, 2 plus 1 is 3. The end. Alright. Now, and remember, since this is a video that I'm doing live from my home, it's not really live to you. You could pause and stop and rewind whenever you want. Okay, so next, if I subtract it, so let's say we're going to subtract 1. Where's the black marker? Alright, I found the lid, and there's the black marker. Okay, so now I want 6x squared plus 5x plus 2, 50, minus, let's see, 4x squared plus 2x plus 1. Now, we're going to have to distribute again, so we'll put our imaginary 1 in here, like that. So now I've technically got, because I'm not looking at any of the rest of this, I have a negative 1 times a 4x squared, a negative 1 times a 2x, and a negative 1 times a positive 1. Because I'm going to distribute just like I did before. And I'll rewrite it in green. So now I've got 6x squared plus 5x plus 2 minus 4x squared, because I distributed, minus a 2x, again, minus a 1. So now I'll go back to my red. Again, just combining like terms. So I've got 4x squared and a 6x squared, but here's a minus. So this is minus just this individual piece right here. So I have 6x squared minus 4x squared. 6 minus 4 is 2. So now I've got 2x squared, and I can cross those out. Next up are my individual x's, so x to the 1 power, because there's always at least something up here. And right now there's an imaginary 1. So x to the first power is just x. So we don't have to write the 1. But, so I'm going to combine my terms, so I have 5x, then again there's that minus, so I have 5x minus 2x. Well, 5 minus 2 is 3, so I have minus, oh wait, it's positive. I have to erase it. But so I have a positive 3x left, and I can cross those out, and now I have a positive 2 minus 1. And there we go. So I was adding and subtracting polynomials. Alright, now let's do a little multiplying. Let's multiply some polynomials. Alright, so I'm going to do 3x plus 1. Now these parentheses here, I'm going to make them really clear. This is the quantity of, so this is the quantity, this is the whole thing right here. And then I have a separate set of parentheses, and I'm going to put in 2x minus 4. Because it could be any kind of numbers, it doesn't matter, any kind of coefficients, it doesn't matter, because we're multiplying, and you'll see that. So I'm going to take my green. Now I'm multiplying this. This is, I mean, just think of this the same way as if I said multiply 3 times 2. Alright? This is the same as writing 3 times 2, 3 times 2. This right here, you're just multiplying a few more numbers. It's the same as writing this in parentheses. So this, there's like an imaginary times symbol right there, a multiplication symbol. This little dot right here also means multiplication. And then, of course, we've all seen this x a whole bunch of times, and that means multiplication. So when you see it, you just have to remember that in math, there's a few different ways to do things. It all depends on, like, I don't know what country you came from, what city you went to. I mean, so many different people do it different ways. As long as you get to the right answer, just find your way. Alright, so back to the problem at hand. Alright, so we're going to distribute. But the way that we distribute, you got to pay real close attention. So I'm going to take my first term right here. So this is my first term, this is my second term, this is my first term of the second polynomial, or binomial, I'm sorry. And here's my second term. So I'm going to take 3x times 2x. That's it, just 3x times 2x. 3 times 2 is 6. X times x is the same as if I said 4 times 4. You could say 4 squared because it's 4 times itself. It's 4 times 4. So I'm going to say x squared because it's x times x. So now I've got 6x squared. Alright, so now that step's done. Now I'm going to go again, do the exact same thing. So 3x times a negative, because there's a negative, that minus sign right there, negative 4. So the numbers by themselves, it's a 3 times a negative 4, that's negative 12. And then I have that x, and there's no other variables, so the x stays by itself. So now I have 12x. Alright, now the first term's completely done. I don't have to touch the first term ever again. Now the second term, I'm going to go this way, make it a little more clearer. I might even use a different color. Alright, so I'll bring out my red. So now I've got a positive 1 times a positive 2x. 1 times 2 is 2, and there is no other variable, so it's still the single x. So now I have a positive 2x. Now I do it again. A 1 times a negative 4. 1 times negative 4 is negative 4. 4 times itself, and then the negative sign. So minus 4. 4 times 1, negative sign. Alright, so then I look to see if I can combine like terms. When you think of this, think of how when you reduce something, if I gave you a fraction and I said reduce it, I'm going to give you this polynomial and tell you to reduce it. So I'm going to look for like terms. Well, I've got my x squared here, and I look across and I don't see any other x squared, so I can't combine them. I just put it down. So I've got blue. So now I've got 6x squared, and I can cross that out, so I'm not touching it again. Now I go to my next number. Here's a 12x, so I look to see if I have any other single x's by itself, and I do. Here's a 2x. I look at my numbers. I've got a negative 12 and a positive 2. That gives me a negative 10, because negative 12 plus 2 is negative 10. My x's don't change because I'm not multiplying, I'm just adding. So now I have minus 10x, and I can cross these out, and then the only thing I have left is a 4. So I put my minus, because there's a minus sign here, it doesn't change. I put my minus 4 here. And that's a 4. I told you sometimes this doesn't work. Alright, so I have I've taken these two binomials, I've multiplied them times each other. I came up with this long drawn out expression, and then I reduced it. I combined like terms. Okay? Now this is just one of those things, like anything in math, it just takes a lot of practice. The more you can practice it, the better you're going to be. So even if you're watching these videos, if you just want to take notes separately over to the side, excellent idea. Excellent. You're good. Okay. Alright. So, what do I want to do next? I think I'm going to end this video, and then I'll start another one that is just multiplying random binomials that I can come up with. Good? Good. See you later. Bye, bye, bye!